All right, good morning. Let's look at page NOS 15 in our textbook. So hopefully you've read through lesson 2, and we're going to look at significant digits. So we're going to do a little bit of math in today's lesson. Turn my volume up. So significant digits in your textbook says are the number of digits in a measurement that are known with a certain degree of reliability. So let's look at those rules here. Rules 1 through 4 in table 5, and you can also see them here. As we read through, I want you to follow along at the rules. And then when we start working the problems, I want you to put these problems in your science journal. You're going to need to tell me which rules apply and the number of significant digits. So I want you to do yours in your journal just like I'm doing mine on this paper. So significant digits. These are digits that are known with a certain degree of reliability. If we were to look at a thermometer and it had we were looking at the temperatures of 183 degrees. Let me write this down. 183.2 degrees, and then we had 183.3 degrees, and the temperature fell right in between those two digits. I don't know if you can see that. Sorry, let me move my camera. We could estimate that it would be 183.25 would be the more accurate measurement. So these are numbers with a certain degree of reliability. So let's look at these rules. Rule number 1, all non-zero numbers are significant. Rule number 2, zeros between non-zero digits are significant. Number 3, final zeros used after the decimal point are significant. Rule number 4, zeros used only for spacing the decimal point are not significant. Okay, first thing, let's look at these practice problems here, and hopefully you can see them, and I want you to write them down in your journal as well. So I'm going to make me a table, and I'm going to write SD, draw a line, and rules. So SD is going to stand for significant digits and rules. Okay. So there we go, and I'm going to do it on this side as well. So the directions say how many significant digits are in each number and tell which rule applies to the numbers. So SD and rules here. Now, number 1, it says, 17.453. Let's scoot it over so you can see it. 17.453. We have to go through each one of these rules to determine if the rule applies or not. So let's see. Rule number 1, all non-zero numbers are significant. So is rule 1 being applied? Well, that's a non-zero, that's non-zero. All of these are non-zero. So I'm going to write, okay, rule 1 is being applied. I'll write that down. Let's look at rule 2. Zeros between non-zero digits are significant. Well, there's no zeros in my number in this first number, so I'm not looking at rule 2 anymore. It doesn't apply here. Final zeros used after the decimal point are significant. Well, I have no final zeros, so I'm not using rule 3. Rule 4, zeros used only for spacing the decimal point are not significant. Well, I'm not using that either. So I'm using rule 1, and then I count my tick marks to see how many significant digits I have. I have 1, 2, 3, 4, 5. So I have 5 significant digits, and I used rule 1. So that's how you do every problem like this. So rule number 2, 1.01. Let's look at the first rule. All non-zero numbers are significant. So I know this one and this one for sure. Okay, so I write rule 1 down. Number 2, zeros between non-zero digits are significant. Well, this 0 falls right in between two non-zero digits, so I'm going to use rule 2 now. Number 3, final zeros used after the decimal point are significant. I have no final zeros after the decimal point, so I'm not going to use rule 3. Number 4, zeros used only for spacing the decimal point are not significant. So I'm not going to use the rule number 4 because this one is significant for this one, even though it is for spacing, but it is a significant digit because of rule 2. So I have 1, 2, 3. 3 significant digits here. Does everybody see that? I put the number of my significant digits after I figured out my rules. Let's look at this one, 0.0100. All right, so the first rule, all non-zero digits are significant. I know I use rule 1. Number 2, zeros between non-zero digits are significant. Well, I have no other digit on this side nor this side that's a non-zero, so I'm not going to use rule 2. Number 3, final zeros used after the decimal point are significant. I'm using this 0 after the decimal point and this one. Those are 2 final zeros because there's no digit on this side. So I am going to use rule 3. Okay? Number 4, zeros used only for spacing the decimal point are not significant. This 0 right here is being used to to space the decimal point. So I am using rule 4, but remember it says it's not significant. So I have 1, 2, 3 significant digits, and I used rules 1, 3, and 4. This one was not significant because that's based on rule 4. It says they're not significant, but I still applied that rule. Okay, let's look at number 4. Number 4, 12,003,000. All right, first rule, all non-zero digits are significant. So that's going to be this one, and this one. So we use rule 1. Number 2, final zeros, it says, zeros between non-zero digits are significant. Well, these 2 zeros fall in between non-zero digits. So I am going to use rule 2. Okay, let's look at number 3. Final zeros used after the decimal point are significant. This is where a lot of people make a mistake. That is not a decimal point. That is a comma. Okay, so I'm not using rule 3. Even though these are final zeros, there's no decimal point. Okay, we're not done. Rule 4, zeros used only for spacing the decimal point are not significant. Even though there's not a decimal point, these digits right here are space holders, okay? Tens, hundreds, thousands. Those are space holders. But it says they're not significant. So we do use rule 4, and then we count our number of significant digits, 1, 2, 3, 4, 5. We had 5 significant digits, and we used rules 1, 2, and 4. Everybody see that? So these are final zeros, even though there's no decimal point. I'm sorry, let me restate that. These are space holders, tens, hundreds, ones, tens, and hundreds. They are space holders, but they're not significant based on this rule, okay? Number 5. Hopefully I didn't confuse you there. 0.00031. Be sure you're writing this down as we go. Rule number 1, all non-zero digits are significant. Okay, we know we use rule 1. Number 2, zeros between non-zero digits are significant. Well, there's no digit over here, so therefore I can't use these zeros to count them. Okay, so I'm not going to use rule 2. Rule 3, final zeros used after the decimal point are significant. Well, these zeros come after the decimal point, but they're not final because I have digits on this side. So I'm not going to use rule 3. Rule 4, zeros used only for spacing the decimal point are not significant. This is used for spacing, this is used for spacing, and this one is used for spacing. So I do use rule 4, but they're not significant. Remember, that's what the rule says. So I have 2 significant digits, and I use rules 1 and 4. Last one, 88.0. So all non-zero digits are significant. We know we use that one. Zeros between non-zero digits are significant. Well, there's no other digit over here to count this 0, so we're not going to use rule 2. Final zeros used after the decimal point are significant. This is a final 0, so we do use rule 3. All right, rule 4, zeros used only for spacing the decimal point are not significant. We do not use rule 4, okay? So we have 3 significant digits, because remember, rule 3 is applied here. And we use rules 1 and 3. So hopefully you took good notes. Hopefully this makes sense. If it doesn't, send me an email. Go back through your rules every time you do a problem. Go through each rule so that way you won't skip any steps. Then count your number of significant digits. If you do it like I did and count the tick marks, you'll do it correctly, okay? You are going to have some practice problems in Google Classroom. I want you to work on those. You're going to tell me the rule for each one that's being used and the number of significant digits. Okay? Thank you guys for listening.